The key with the composites, I find, is that your first step is best if you try to find a flat surface to get the area of, and then apply the principle of going up a certain height. So I'm going to look at this figure this way. On this front, I have a triangle and a rectangle, and that represents an area I can find. And then I'm going to take that area and I'm going to extend it along the height of the prism. So I'm effectively going to lay this prism on its side and stretch it up. So instead of trying to find the area of that triangle on the top and the box on the bottom and add them together, I'm going to find the area of that front, the area of the base, and I'm going to multiply that by the height. So rather than seeing it as two objects that are glued together, it's one prism that's been stretched up. It's a stack of little cardboard cutout houses that are all glued together to create a 3D house. So let's go ahead and start looking at how to get that. Now the good news, this piece right here, this front rectangle, that's easy. That's just 8 by 5, or 40 square centimeters. Because that height of 5 is consistent on the front and the back of my house. The hard part is going to be that triangle at the top. This piece right here. That's going to take the work to get. Because I don't actually have the height of it. All I know is that that triangle, I'll draw it over here, is 8 units on every side. It's equal angular, equilateral. But what's the height of it? I need, in order to use the area of a triangle formula. Yeah. Yes. Pythagorean theorem is how we get this. He's got the measure of this. Don't be second guessing my man there. That's 8 there. How long is this base down here? 4. Pythagorean theorem tells me this side's going to be 4 times, let me rewrite that. Clean that up. Pythagorean theorem will give me this piece over here is 4 square roots of 3, which is the same as 4 times the square root of 3, 6.9. Now, excuse me, you could also note that because it's equilateral, it's equal angular, so that means that it's a 30, 60, 90 triangle. And you can use the rules for 30, 60, 90s to get that 4 root 3 or 6.9 just as easily.
Can you just round it 7?
I'm already rounding it a little bit to get to 6.9. I'd be hesitant to round it straight to 7. A chemistry teacher would argue that we only have one significant digit so far, so you should. I wouldn't. Actually, what I would do, I would preserve this in my calculator as much as possible so that I have a lot of those extra places I don't round. So now I'm going to take the 6.9, which in my calculator says 6.92822032, multiply that by 4, and that's where I get my answer, 27.7. Plus the 40 for the rectangle under it, gives me 67.7 as the area of that front piece. How are we doing so far? What can I say? Or should I clarify? I will say this while we're kind of getting caught up with our notes. This area of an equilateral triangle, where they just give you all 3 sides are the same value, is kind of something you're expected to be able to do by now. So even though it's not a straight up half base height kind of answer, you really do want to double check to make sure you're comfortable with that. So now I can go ahead and get my volume for the composite, area of the base, times the height. It's a 6 point, oops, not 6 point. 67.7. That's the area of that front piece. Times a height of 4 centimeters. Gives me a volume. Call it 270.8 square centimeters, or cubic centimeters. Square centimeters from the base, 1 centimeter from the height, cubic centimeters to finish it out.
So you take the area of the front piece, and why do you multiply by 4?
Because I'm treating that front piece on there as the base, and I'm pulling it back 4 units to create a height.
Oh, alright.
I'm taking the prism, kind of let me look at the prism this way. See if I can draw it. I'm taking the house and I'm laying it down so it's flat. And then like that. So now I've got my box, my triangle on the ground, and I'm pulling it up a certain height. Kind of the same concept. What else can I say about this problem? And this is a good example, I think, of where finding that base and stretching it is a lot easier than trying to add volumes together and find them all individually.